over B. This is a fraction. A is referred to as the numerator. The numerator. While B is the denominator. These are, of course, naturally occurring whole numbers. So A is a whole number and B is another whole number. This makes a fraction. Now, there are different types of fractions. We have a fraction in which the numerator is lower than the denominator. This is a proper fraction. This is a proper fraction. We have fractions in which the denominator is greater than the numerator, something like 7/3. This is an improper fraction. Improper fraction. And now the improper fraction can be converted into a mixed fraction by division. 3 divides into 7 gives us 2, leaving a remainder of 1. And we place that over the original divisor, which is 3. And now we have a mixed fraction, which consists of a whole number part and a proper fraction part. So this is mixed fraction. All right. So we're going to look at the operations involving fractions now. So that is it. That's the numerator on the denominator, and then we have the proper, improper, and the mixed fraction as types. All right. Now we are looking at the operations involving fractions, addition and subtraction, the first area. So let us get into it straight away. And we have to take these traces away. So addition and subtraction. Let us look at an example. In the first example, we have 1/3 plus 2/5. And now we're going to find the LCM of the denominator straight away. So let's go for the LCM of the denominator. This is our first problem. And then the LCM of 3 and 5, clearly, 15. The number into which 3 can perfectly divide, and then 5 can perfectly divide into it as well. That's 15. So 3 divides into 15, gives us 5. That 5 multiplies this numerator 1. The 5 multiplied by 1, that gives us 5. Then plus 5 divides into 15, gives us 3. 3 multiplied by 2 gives us 6. And the final answer can be written. This is going to be 5 plus 6. That gives us 11. Now over that denominator 15. And we have the final answer. Very simple. Let's consider the second problem. In the second problem, we have compartment A. We have 1/4 with a whole number, 3 whole number, 1/4, now minus 2/3 as our second problem to be solved. Now, okay, let's make this a mixed fraction into, convert it into a single fraction, which is the improper form. So 4 multiplied by 3 gives 12. 4 times 3 is 12. That 12 plus this one gives us 13 over the original denominator, which is 4, minus 2/3. This keeps it simple. And we can find the LCM of the denominators now. LCM of 4 and 3, that is 12. So 4 and 3, we divide into 12 without leaving a remainder. And 12 is the simplest number, of course. We can divide into. 4 divides into 12, that's 3. 3 multiplied by 13 gives us 39. And now minus 3 divides into 12, that's 4. 4 times 2, that gives us 8. And now we have 39 minus 8 gives us 31. And now divided by 12. And we can change this into mixed form. Or 12 divides into 31, that is 2. That's 24. Remainder 7 over 12. Our final answer. Very simple. Let us solve the third one. The third example. Addition and subtraction, how we can add and subtract fractions. Third example involves 3 fractions now. So we have 3/5 plus 1 whole number, 3/4. and now minus 1 over 2. So the best practice here is to express the numbers as single fraction. This is a single fraction already, 3 over 5. That's a single fraction, 1 over 2, a single numerator and a single denominator. But this is mixed. So we have to convert the mixed fraction into a single form. And that means we're going to have 3 over 5 plus, let's convert now, 4 times 1, that's 4. 4 resulting plus 3 gives us 7 over 4. And then we have minus 1 over 2. Now we're going to find the general LCM of these three numbers in the denominators. The LCM of 5, 4, and 2. The number into which each of these we divide without leaving a remainder. Of course, that's 20. 5 divides into 20, that's 4. 4 times 3 gives us 12. Plus 4 divides into 20, that's 5. 5 times 7, that's 35. Now minus 2 divides into 20, that's 10. 10 times 1, and that's just 10. And we can allow the numerators to interact according to the sign separating them. Let's take the positives together first of all. 12 plus 35 gives us 47. 47 minus 10 gives us 37 divided by 20. And this is the answer. Only we can express it as a mixed fraction. 20 divides into 37 only once, that's 1. Remainder 17 over the original divisor, which is 20. Our final answer. Very simple. So that's how addition is done. Let's proceed into the next area. Multiplication and division. Of course, I'm taking off the traces. All right. Multiplication and division of fractions. So we have the operation times and the operation divide. Simply, the operation divide in between fractions is converted into a times with the inversion of the fraction on the right-hand side of the times, which means the original denominator will get up into the numerator area, and the original numerator will also get into the denominator area. All right, so let's have an illustration. For example, let's have an illustration. This having been understood, I'd like to clear the traces. All right, now let's start with the first illustration. 2 over 5 multiplied by 3 over 5. It's beautiful. Now we look at this. When it comes to fractions multiplying itself, factors that are common in the numerator and denominator can be cancelled out. In this case, there is no common factor. So the solution is simply we multiply the terms in the numerator together and also multiply the terms in the denominator together to get our final answer. And that means we're going to have 2 times 3 in the numerator, and that's going to give us 6. That's going to give us 6 divided by 5 times 5 in the denominator, and that gives us 25. Our final answer. Very simple. Let us look at another example, B. The second example, we have 5 over 12 divided by 3 over 8. Beautiful. And now here comes the division sign. So we have to change division into multiplication and invert the fraction on the immediate right. And this is going to fetch us 5 over 12. Change the division into multiplication times. Now inversion of the fraction on the right, of course. 8 becomes the numerator, while 3 becomes the denominator. So we write very quickly 8 over 3. And now we have to inspect, do we have common factors dividing through the numerator and denominator? Inspect 5 and 3, nothing is common. 5 and 12, no. Now we're looking at 8 and 12. And of course, what are you thinking of? 4 can divide. 4 divides into 8, that's 2 times. 4 divides into 12, that's 3 times. And now we can multiply the remaining figures. 5 times 2 in the numerator, 10. Divided by 3 times 3 in the denominator, that's 9. And that's our answer. Or would you like the mixed form? 9 divides into 10, 1. Remainder 1 all over 9. Very simple, our answer. Let us look at the third example for this. Multiplication and division. Now we have 3 whole number 1 over 4. Divided by 3 over 8. And now let's convert the mixed fraction into a single fraction. So this is going to give us 4 times 3, that's 12. 12 plus 1 gives us 13 over 4. And now let's take that time to change this division into times, multiplication, with the inversion of the fraction on the right-hand side. So 8 steps up as numerator, and 3 interchanges with it into the denominator area. Now, are there common factors? Of course, 4 divides 4. 4 divides into 8, and that's 2 times. And now we have, this is going to give us 13 times 2, that's 26, over 3 times 1, that's 3, or the mixed form. 3 divides into 26, that's 8 times, 24, remaining 2 over 3. Our final answer. Very simple. That's beautiful. Okay, let's step it up into mixed operations now. Mixed operations, the next area. Mixed operations. For this, we have to take the traces away. In mixed operations, we simply modify the BODMAS rule in simple terms. So let's do the modification of BODMAS in simple terms. It means we first simplify expressions in brackets. So deal with expressions in brackets first. Deal with expressions in brackets. That's the first thing to be done. First, deal with expressions in brackets. So we take the expressions in the brackets or in the parentheses and simplify them first. Now, one more, expressions separated by times or divide should be taken together. So terms separated by times or divide must be taken together. They are inseparable. Terms separated by times or divide must be taken together. They must be taken together. Do not try to separate those terms. Taken together. Do not try to separate those terms. Once two fractions are separated by times or by divide, they go together. Now, off should translate into times. Off should translate into times. With these three rules, we have the BODMAS rule taken together in one unit. Let us go and look at some illustrative examples. Let's go. So for mixed operations, I have to take these traces away. All right, let's take a few examples. So the first example, simplify. Let's simplify. Simplify. Simplify means make as simple as possible. Simplify. 3 over 1 over 4. This is the first one. 3 over 1 over 4 minus 2 over 1 over 6 and times 3 over 4 plus 1 over 4. Look at that. So this is a mixed operation. We have minus, times, and plus in this same problem. And from the rule, we have seen that the expressions containing times in between them must be taken together. This is the only thing we need to do. Now let us change everything into single fractions. All mixed fractions should be typed as single fractions. 4 times 3, that's 12, plus 1 gives us 13 over 4, minus 6 times 2 is 12. 12 plus 1 again, 13 over 6. Now we have times. This is 3 over 4. And plus, of course, 1 over 4. Now, taking the expressions separated by times together, we can simplify them as a single unit before we proceed. So let's see what factors are common. Upstairs and downstairs. 3 divides into 3, 1. 3 divides into 6, that's 2. And now we can take numerators together and, of course, denominators together. So 13, we have to multiply 1. And, of course, 4, we have to multiply 2 that way. So now we have, it is equal to 13 over 4. The minus sign between them sustained, yes. And then we multiply 3 times 1, which is 3 in the numerator, and 2 times 4 here, and that's 8. Now plus 1 over 4. And now we can find the LCM. The general LCM of these denominators, 4, 8, and 4, is simply 8. All of them will divide into 8 without leaving a remainder. So let's go. 4 divides into 8, that's 2. 2 times 13, that's 26. Minus 8 divides into 8, that's 1. 1 times 3 is still 3. And now plus 4 divides into 8, that's 2. And 2 times 1 gives us 2. And now we can finish it off. 26, the positive ones together, 26 plus 2, that's 28. 28 minus 3, and that gives us 25 over 8. Or should we have a mixed fraction? 8 divides into 25, that's 3 times, leaving a remainder of 1 over 8. Our final answer. Very simple. Let us solve the second example. Example B, we're asked to simplify. Let us simplify 1 over 2. 1 over 2 of 4 over 5 minus 5 over 6 and divided by 2 over 3 plus 2 over 5. That's right, 2 over 5. And now let's take care of the off. Yes, right there, and the divide. 2 of them should be taken care of. You can see clearly. Off. Must translate into times, of course, and divide must also translate into times, of course, with the inversion of the fraction on the right. So this is going to give us, of course, this is going to give us, it is equal to 1 over 2 of translate into times. But this time around, the fraction will be intact because this is off. So we have 4 over 5 minus 5 over 6. The divide will translate into times with the inversion of the fraction on the immediate right. So 3 upstairs divided by 2 downstairs. And finally, plus 2 over 5. Now, at this point, let's recognize expressions that have times in between them. 2 fractions separated by times must be taken together. Separated by times, these 2 must be taken together. So let's simplify these 2 very quickly. 2 can divide. 2 divides into 4, that's 2 times. In a similar manner, 3 can divide 1. 3 divides into 6, that's 2 times. And now we can tidy this up as single units. So 2 times 1 right here, which is 2, divided by 5 prevailing underneath. Minus sign sustained. 5 prevailing up, divided by 2 times 2 underneath, that's 4. Finally, plus 2 over 5. Now we have simple fractions, single fractions all the way. So let's find the general LCM. General LCM of 5, 4, and 5. Can you figure it out? Of course, 20. 5 divides into 20, that's 4. 4 times 2, 8, minus 4 divides into 20, that's 5. 5 times 5 upstairs, 25. And finally, plus 5 divides into 20, that's 4. 4 times 2, that's 8. And now we can simplify this. Let's take the positives together. 8 plus 8, that's 16. 16 minus 25 gives us negative 9 divided by 20. And this is in its simplest form, our final answer. Very simple. Very, very simple. Now we still have more. So let us clear the traces for this. We still have more. Let's clear the traces and solve 2 more questions on this. So let's solve 2 more. So illustrate example C. Let's simplify. Simplify. 2 over 3 minus 1 over 2 multiplied by 5 whole number 1 over 4 divided by 2 whole number 1 over 3. Let's have this simplified. Now the expressions in the bracket should be simplified, taken as a whole unit. Times retained, and then that divide should translate into a times with the inversion of the resulting fraction. That's right. So let's get into it. Let us simplify the expression in bracket. So let us have it. The LCM first. LCM of 3 and 2, that's 6. And 3 divides straight away into 6 to give 2. That 2 resulting times 2 gives us 4. Minus 2 divides into 6, that's 3. The 3 times 1 on top, and that is 3. Expression in the bracket. Let's retain our times and now make this fraction to be simple in simple form. That's single units. 5 times 4 is 20 plus 1. That gives us 21 over 4. And now we have to take a moment to make this a single unit, a single fraction. 3 times 2 is 6 plus 1. That's 7 divided by 3. Beautiful. Now we have to find the resulting simple expression here. 4 minus 3, that is 1 over 6, and there's no need for the bracket anymore, times, this is 21 over 4. And now we have to change divide into times with the inversion of the fraction on the immediate right. So 3 take on the position upstairs over 7 downstairs. Now we can simplify. Are there factors that can divide in the numerator and denominator? Let's find out. Very quickly, notice 7 is around here. 7 can divide into 21 to give us 3. That 3 resulting can divide into 6 to give us 2. And now we can simplify by multiplying all factors remaining in the numerator. 1 times 3 resulting, and that is 3, divided by that remaining in the denominator, 2 times 4, and that gives us 8. Very, very simple. That's right. Very simple. Okay. Now let us look at the second example in this. We're still looking at mixed operations. The second example and the final example for mixed operations. So this video furnishes you with examples so that the learning is full. All right. So when we repeat solutions of different problems, 3.5, simplify, 3 whole number 1 over 2 plus, now here comes an expression in the bracket. We have 2 whole number 1 over 3 minus 2 over 3, now divided by 2 whole number 7 over 9. All right, let's get into it. So the expression in the bracket should be simplified very quickly. And let's take that opportunity to make the mixed fractions as single units. There we go. 2 times 3, that's 6, plus incoming 1 there, 7, over 2, the original denominator, plus the expression in the bracket. We have to make a single unit also. 3 times 2, that's 6 plus 1, 7 over 3, minus 2 over 3. All divided by, let's make this a single unit also. 9 times 2 is 18. 18 plus 7, that's 25, divided by 9. That's right. And now we have to simplify the expression in the bracket as a single unit. This is a simple fraction. The denominators, notice the denominators are the same. And under this condition, we can simply allow the numerators to interact after the order of the separating sign. The denominators are the same. You can see that. 3 each denominator. So we can simply allow 7 to subtract 2, 7 minus 2 there. So let's write 7 over 2, the original fraction here. Now plus the result of the bracket. 7 simply minus 2, that's 5. Over that common 3 they both have. This is a quick technique in dealing with fractions. So if you have something like 5 over 7 to minus 3 over 7. On citing, look at that. 7 in the denominator, each of them. 7 is the denominator. The answer, resulting answer, we also have that denominator 7, but with the interaction of 5 and 3 after the order of the sign separating them. So 5 minus 3 straight away, that's 2. So there's no need to waste time looking for the LCM in this case. If you have the same thing, 4 over 9 plus 6 over 9. Now you can see the denominators once again are the same. Simply, the final answer, we have that common denominator, and then there will be interaction of the numerators after the order of the sign separating them. So 4 simply plus 6 gives us 10 over 9, and you can take that to mix like that. So let's proceed with the work. I'm taking these traces away so that we can have our space for work. So the expression in the bracket has been taken care of. The next thing is to look at that division sign and then do the right thing. The division sign will translate into times, and then there will be inversion of the fraction on the immediate right. 9 go into the numerator area, divided by 25 in the denominator. And now what is common in the numerator and denominator? 5 can divide, goes here, 1. 5 divides into 25, 5 times. 3 divides, 1. 3 divides into 9, that's 3. And now we have this will give us, multiply everything you see in the numerator. 7 times 1 is 7. Multiply by 3 is 21. Divided by 2, simply times 5, and that's 10. Or we can write in mixed form, 10 divides into 20, that's 2 times, with the remainder of 1 placed on the original divisor, which is 10. Our final answer. Very simple. You can see that. Very, very simple. Okay, let's still enjoy more examples. Mixed fractions. Let's enjoy more. For the next, I'd like to show the concept of mobile denominators. So let me show the concept of mobile denominators. I'd like to It's a beautiful concept that can make work easy in operations with fractions. Mobile denominators. So let me share this. The concept of mobile denominators. Now, when a fraction is written on another fraction, then the denominators are mobile. One way to take care of this is to simply say, okay, A over B, the main division line is extended for clarity, and then over C. The denominator on top of the division bar sinks to join the numerator in the fraction underneath. And this is simply going to give us A prevailing in the numerator over B, join mobile to C, BC. Simple, very simple. The clarification is simply A over B is being divided by C. And writing C as a fraction, we can place it on 1 to make it a fraction. So the rule says change the division into multiplication, and this is going to give us A over B multiplied by 1 goes up over C. And now we can multiply the numerators out. A times 1, that's A, on top of B times C, and that's BC. The same answer we got earlier in 1 stroke. So in standard tests, where calculators are not involved, standard tests like this SAT, like the UTME exams, and of course other similar exams, we can avoid this volume of work here and effect a single strike. Mobile denominators, very beautiful. Let us extend it. Supposing we have another variation of this, A now over B over C. Look at this. It seems we've written the same thing, but not exactly. A number is written on a fraction. That is the main division bar. So the main division bar has the denominator under it. The denominator under the main division bar now is mobile, and we get into the numerator area in one stroke so that we can write AC simply on B. Mobile denominators, very simple. So this is the clarification. We can have this is the same as saying A is to be divided by B over C. And you see, let's write A as a fraction so that it looks like the fraction on the right. So we have, it is A over 1. And observe our rule, change the divide into times. In fact, the fraction on the right, C go upstairs over B. And by merging this in single units, you have A times C, which is AC. All of this over B times 1, which is B. Exactly what we have again. So we, once again, bypass that volume of work. So if we have something like 2 over 3 over 4, very quickly, we can take this in one stroke. That is the main division bar. And now we have the denominator that is mobile. So 4 multiplied by 2 straight away is 8 over 3 in one strike. That's right. Okay. More to it. How about a fraction on another fraction? What do we do? Mobile denominators. The denominators we simply move. So if we have the third form, which is A over B, all over C, now over D. What do we do? That is the main division bar. So we have the denominators we have to move. The denominator underneath the division bar, we move and interact with the numerator up. The denominator above the division bar, we have to sink to join the numerator underneath. In one stroke, the answer can be written. So we have D move upstairs to join A, we have AD. On B, sink downstairs to join C, we have BC. In one stroke, and we avoid the long writing, which is A over B divided by C over D. We have to set it down to do this, which is A over B, change the division into times, invert the fraction on the right, which is D over C. And that means link the numerators multiply, A times D, that's AD, over B times C, which is BC. So we can practically do that in one stroke, and exactly the same answer we have. You can see that exactly by bypassing this volume of writing here. So next time you have something like 2 over 3 divided by 5 over 7, the answer can be in one stroke, of course. So straight away, the denominator 7 multiplies the numerator up. The denominator 3 multiplies the numerator down, which is 5. And this in one stroke will give us 7 times 2, 14. Over 3 times 5, 15. In one stroke. And we bypass the volume of work that would have been done. All right. Let us look at an application involving this. So for that, I have to take these traces away. Let's go. Please come with me and stay with me. Now we have the first one, simplify. Simplify. 2 over 3 plus 1 over 5. All divided by 5 over 6 minus 1 over 2. Beautiful. And you can see a combination of fractions in the numerator, another combination of fractions in the denominator, as you can see. So we have this is going to give us, let's begin. We have to find the LCM in the numerator. So the original numerator, the LCM of 3 and 5 is 15. And now 3 divided into 15, that's 5. That 5 resulting times 2 upstairs, that's 10. Minus 5 divided into 15, that's 3. The 3 times 1 on top, that's 3. Now all of this divided by, so I have to extend the division bar to distinguish it from this one up here. LCM of the bottom 6 and 2. There are many ways to deal with this. I'm going to show a quick technique after this. So LCM of 6 and 2 is 6. And 6 divides into 6, that's 1. 1 times 5 is 5. Minus 2 divides into 6, that's 3. 3 times 1 there is 3. Beautiful. Now we can simplify further. 10 minus 3 up there, and that's 7 over 15, all divided by 5 minus 3, and that's 2 over 6. We can take a moment to simplify further by saying 2 divides 1, 2 divides into 6, and that's 3. So that encourages the writing. 7 over 15. All of this divided by 1 over 3. And now here comes mobile denominators. So 3, we have to multiply 7 up there, while 15, we have to multiply 1 underneath. And that makes us have 3 times 7 up there, 21. Over 15 times 1 underneath, 15. And now let's look at it. There is a factor that is common. Of course, 3 can divide. So let's simplify further by dividing by 3. 3 divides into 15. That gives us 5. 3 divides into 21. That gives us 7. And now we can have 7 over 5 as our final answer. Or the mixed fraction. 5 divides into 7. That's 1. Remainder 2 divided by 5. Our final answer. Very simple. We take on the next one. Let's take on the next one. Simplify. 3 over 4 of 2 over 5. If you know you can handle this, you can pause the video and solve it, and then check your answer. 1 over 3 plus 1 over 4. We follow our rules. Of translates into times. So this is going to give us of translates into times. We have 3 over 4. Of translates into times. That means we have times 2 over 5. Let's have a mixed fraction there. So 3 times 1 is 3 plus 1. That's 4 over 3. Then plus 1 over 4. And this is going to give us, let's tidy up this further. 2 can divide 1, 2 can divide into 4, and that's 2. So let's make it a single unit. 3 times 1, that's 3. Over 2 times 5 up there, that's 10. And now, let me take a moment and show you mobile denominators. Now, a process known as double crossing can be done. If you have 2 fractions interacting, 4 over 3 plus 1 over 4, you can, of course, do something very quick here. Of course, you can do what we call double crossing. 4 has to multiply this 4. 3 has to multiply that one, and then 3 has to multiply 4. And you have the answer in one stroke. Let's go. 4 multiplied by 4, that's 16. Let's record the 16. And we have 3 times 1, that is 3. These two results will interact according to the sign separating them, plus. So 16 plus 3, that gives us 19. And now 3 times 4 to define the new bottom. 3 times 4, and that's 12. In one stroke again. This is a process called double crossing. So we have 9 over 12 as the interaction there, 9 over 12. Or you can simply enjoy finding the LCM and solving. 9 over 12. This is double crossing. I hope you learned that. I'll give another illustration. Supposing you have 3 over 5 minus 1 over 4, and you want to be vigorous with this. Very simple. Do the double crossing, starting with this expression. Starting with the bottom right. 4 times 3, that's 12. We'll do 12 in abeyance. Minus, double cross this. 5 times 1, that's 5. So the 12 resulting minus 5 after the order of the sign separating them. 12 minus 5 gives us 7. Divided by, now multiply. 5 times 4, simply 20. So you may bypass the LCM process. Very simple, isn't it? So that's another way to be quick in standard tests like the SAT, the UTME, even the SSE examinations. All right. Double crossing makes you smart. Very smart. All right, we'll proceed. Mobile denominators here, 12, we have to go upstairs, multiply 3. That's right. And now 10 multiplies the 9 there. So we're going to have 12 times 3, and that gives us 36. Divided by 10 times 9, and that's 90. Your timetable, your multiplication table must be alive in you to enjoy this type of works. Multiplication table, at least up to 12 multiplication table should be alive. And we can divide. What is common here? What can actually divide? 9 can divide. Can you see that? 9 divides into 36 4 times. 9 divides into 90, that's 10 times. And now we can divide further. 2 divides into 4, that's 2 times. 2 divides into 10, that's 5 times. And now the final answer is going to be 2/5. Very simple. Our final answer. Very simple. So with that, we complete works on mixed fractions. I hope you enjoyed mobile denominators and, of course, double crossing of fractions. Okay? All right. So stay with me. Come with me. Let's get the traces out of the way. And now we have to take 2 important steps right now. If you have not already subscribed to this channel, please, it's time to subscribe to this channel. This channel has exciting things loaded, inspirational quotes.